Right, let's continue to video 2 of chemical equilibrium, where we interpret uh, the graphs. Now, the first one is the interpretation of concentration versus time graph. So we have the concentration versus time graph. So these are the simplest graph. So we'll see if we can get for the one of rate versus time graph, because we also experience a problem when it comes to the rate graph versus time for the equilibrium. So, but let's start with the simplest one of concentration. They say how to identify which factor between temperature. Remember, the factors that are affecting the equilibrium is temperature, concentration, and pressure. Which one would be? How do we see key factor the equilibrium? Change the equilibrium. Now, here is what they say: if there is a spike or drop on only one curve, then the concentration was increased or decreased. So what is a spike or drop? So a spike will be just a line like this. Now if you see this sharp from the equilibrium, or it can be this sharp from the equilibrium, or on one curve or on one line of the graphs, then it shows that we have changed the concentration of that whether reactant or that product. So if you level to from this horizontal line equilibrium, there is an increase. If you level from that horizontal line, it means there is a decrease on the concentration. Now that is if we see on one line, because remember we might have 3 lines from the equilibrium saying 1, 2, 3. Then here, now we might have one line going up. Then it means the other lines will follow by not doing a spike. Then it means we change the concentration there. Right? If there is a spike or a drop on all curves, now they are saying on all the curves. Now then the pressure was increased or decreased. Now if they're saying they are all the spikes on all the curves, it means our 3 lines like this: 1, 2, 3. And then now we observe a spike, and then now these spikes, firstly I must think they must kind of doing the same. They are all spikes. Maybe they can go like this, another one like this, another one like this. So if that is the case, then it means now there is a pressure that is being increased. And then if it's a pressure, it means that all of those reactions and the products, they must be the gas. So if they are not gases, then it means it will not be a pressure. So but if you see this going all of them, that means the condition or the phases of the reactions and the product is gases. That's why we can say the spike will be there. So the gabadi or it means there will be the pressure there. Now if there is no spike or drop in all the curves, then the temperature was increased or decreased. Now saying that so meaning the 3 lines. Now out of these 3 lines coming from the equilibrium, then was really a spike. Or was not spike, a rising like this, and the other ones will do like this. As long as there is no spike, it means the factor there should be a temperature. So let's check the graph and see what they are saying. The graph on the next page shows that. So let's check that graph and see what's happening. Now let's look at that. This is the lines from the equilibrium. Now this direction. Now our level direction near nearing is already gas come. Can you see a gas, and a gas? So now if you get gas, all the factors the factors can affect the equilibrium. So rather when line in the horizontal like this, now it means from this point up until T1 here, up until T1 there was equilibrium. Now our equilibrium it will be affected now. If affected one level la moran line jarna kam gadian dia change from this horizontal dia change iya tewa kantele spike. So as na spike running right what the factor they see temperature ishi jingoro when outloads but is it increased or decreased now depending on the forward direction, because what of how is our delta here. So then it will which one is increasing, which one is decreasing. And then looking at that again, Razoring N2 and H2 are our reactants, where this one is coming from our products. So these ones are reactants and this will be the products. And then this one, our system, in this case, we run equally. But once we add this one, so some of the things will need to be used up. So our interpreter of for temperature, you cannot, because this is exothermic or endothermic. We'll come back maybe later on the questions. Let's come to the pressure. Now, if you observe here, remember Diller-Lichtenstein principle. On the Lichtenstein principle, now if you check here, there is a spike, another spike here, another spike here. Now, can you see that all the spikes? Then it means there is a pressure. Now, what is happening is that it means there was a decrease. So once the DDF was running, there was a decrease in pressure. So if we decrease pressure in here, it means, remember, a decrease in pressure favors the reaction that result in a high number of moles. Meaning, other words, we have forward direction with the top arrow, and then we have the reverse reaction with the reverse arrow. I mean, already your favor was the direction that is moving towards this side, or the reverse direction in this case will be favored. So if the reverse direction is favored, what does it mean? It means the system, or rather the system, will increase the concentration in here. So the concentration in here is increasing because of this direction to the left is favored. So we expect an increase in these reactions, and there must be a decrease in this concentration of NH3. So let's check. Aggressor graph from 0. You can have the numbers here increasing. So the ones that would be at top, that would be that would be higher than the one that will appear below here. Alright, so our level concentration here, these two, N2 and H3 and H2. So the increase favorably this side. So from that drop, level N2 is now increasing, going up. And then from H2 from decreasing pressure down is increasing. Can you see it's going up? So now it shows that that is the correct theory. Or now already favored, then the side of concentration will increase. But this one, so there must be a decrease kamo side NH3, which is the blue line here. Now that's why it is decreasing here. So the spike, they are showing what happened to the factor. So the size obviously when you are a spike factor pressure. But what happened? If you see the lines going down, then there was a decrease in pressure. But a decrease in pressure, after that, which one is favored? Which line is favored e tlo add ka mona or re addela reactions. That's why the reactions they are come from that there is a spark of decrease in pressure. All of them they're going up like this. Then the one that was doing that, it was now moving down here. So the reactions. That's why we value a decrease, further decrease in here. Right, now the system here again at that is T2, T3. At T4, the system reaches equilibrium again. That's why the lines are running parallel here. It reaches the equilibrium again. Now at T5, now we disturb the equilibrium again. Now already disturb more. What is happening? Arsno disturb more bona when there is a one spike. So if you want one spike here, the rest are not doing the spike. Did you get temperature? Then it means the factor here it will be concentration. I mean, if concentration or concentration ke motho motho one ena ile modimo ore ba okeditse concentration ya hae nka ba e fase wa spike or ba decrease concentration. I mean, aba increase concentration ya ma ke ya N2 or re mo increase in this case re mo ishitse hodimo. So re mo ishitse hodimo or le Chasles principle or system so e shift to cancel this addition. I was a delay concentration or so change o cancel or e change or this re swantse re fokotse motho wa N2 re die a tla tshelle ka so that lo tse di lebeding di be balanced again, because we already di balanced, then coming back or re fitla mo re disturb ra tshela N2. So ra tshela N2 or we edit the concentration of N2 or swantse a tshelle man a tshelle NH3. So wa mo tshella o tlo tjea low. So re expect this one N2 and H2 ba fokotsehe because ba tlo ba tshella. Our system it will favor forward direction while or add more on the right hand side. So re swantse really an increase in NH3 and indeed ka nnete re checka mo re bona an increase in here in NH3 ka go re tshella ka mo yona. And then now the other part drawing N2 re tlo fokotseha sure fokotseha ka baka la re ra mo fokotsa or tshele ka more re kgone balance, but re mo fokotsa a produce NH3 a lete o mo producer a shumisha le H2. That's why the H2 le yena a fokotseha ka moka from that. So but the first one go re bontshe a spike o bontsha there is addition in concentration if spikes is 1. Then after addition when re mo edile o tshwantse a fokotsehe or the reaction e kgone go balance gape, then o ra reng o shumisha le mongwe reaction ra a di ba fokotsehe ba kgone go producer wa tlo oketseha. Now that will be the factor for concentration. That will be the graphs. And then now interpretation of the reaction rate. Yeah, this one is it's kind of challenging. Right, I'll go over it then. If you go share the concentration graph, so this one is the concentration versus time. So I want the rate ka khona idea go share interpretation of this. So about the graph yona but remember the following aspects. At equilibrium, the rate of the forward direction and the reverse direction is equal to the rate of the reverse reaction. How do we mean by that? So let's have a draft. This will be time in seconds. Now if this side is the rate, I mean when the rate starts, it means when we start directions, we start only by the forward direction. The reverse direction will start from 0. Because from the reverse the product gets more. Then but our reactions it will show at high rate, and then if a rate like this until they reach equilibrium. And then this other one of the products from 0 because in regards to the routine and projected 7 now they return. Now when they get here, now it means the two reactions they are at equilibrium. Their rate are the same. Running from this level here at T1, they have the equal rate of action, having this one as a forward. So in other words, forward is because at higher rate. Remember, this is 0 and the numbers here is very high, then here is low. So running the one that appears on top a bit running, there must be a high, showing a high rate, and they will come to decrease as time goes by. Then they will reach equilibrium, they run equally. Now it means this other one will be a reverse reaction, this one. Now because now they've reached the equilibrium here. Now we still have our three factors: temperature, pressure, and concentration that affecting the rate of friction. Now how does it go? So let's read the information again. They'll give us what we should do on the graph, or what should we expect if the graph is drawn for us. Right, okay, we interpreted that statement when they're saying at equilibrium, the rate of forward and the rate of reverse are equal. Here, that's when they become equal. Forward and reverse, okay, like equal, it's fine. If the forward direction is favored, here's the forward direction above there. Now we'll see what is happening. If the forward direction is favored, then the rate of the forward direction decreases and the rate of the reverse direction increases. That's it. If forward direction is favored, then the rate of the forward direction must decrease and the rate of the reverse direction must increase. So yeah, let's interpret this statement here, but we must know which factor. They're saying if this one is favored, and then the rate of the forward direction must decrease. How is it decreasing? So it will run from high rate because it's favored. It will be from high rate and then it will come down like this to reach a new equilibrium. And then this other one here, the rate of this one must increase. So how does it increase? So from this level, let's start to increase this one. So they said the forward direction is favored, so this is the forward, and then it means the rate of the forward direction must decrease, so the rate will decrease here, and the rate of the reverse direction will increase. So how does it increase? So from this level, so in other words, let's erase this one, let's interpret it well. Now we're saying the forward direction is favored, so if it's favored, then it must be like this. Yeah, experiencing an error. Let's wait for the machine to respond. Right, here we go. This is forward direction is favored. Then if it's favored, it must go up first. Then now it must do what? It must decrease. Okay, and then now this other one, the reverse direction, must just increase from here to here, and then have the follow to the same rate. That is what is happening here. But we must know what is the factor. So, but that is the first statement interpreted. Let's get this one is interpreted. Let's get to the next one. If the reverse direction is favored, then the rate of the reverse direction decreases and the rate of the forward direction increases. The same applies to this. Then we'll go down, then start to increase. If there is a spike or a drop in only one reaction rate curve, then the concentration of a reactant or product has been increased or decreased. So rather, if there is a one spike like this here, one spike is for this forward direction. Now it means there was an increase in concentration. This one is fall. If there is a spike or a drop for both rates, then it can be temperature or pressure. Now meaning if we come here and maybe increase temperature, then or pressure, they must all go up like this. Now if you see this one, the two spikes going together, then it means now there is a pressure or temperature. Now you look at that. If the reaction about filling yona as a gas, because they say on condition that the substances are gases and the total number of moles of reactant are not the same in the total number of moles. So if you check a reaction on acid gas, then it means now it's not a pressure but a temperature. But if it gas, then check the ratios, both sides, the reactions and the products. If dialgan, then it's not pressure but it's temperature. If dialgan, then it can be a pressure in that case. So rather, if we see the two spikes for both directions, forward and reverse, whether they're going up or down, then there are two factors, temperature and pressure, but we must check pressure on one condition, but temperature doesn't matter on which condition. As long as there are two spikes, then there might be an increase or a decrease in temperature. Right, that's it about the graphs of the rate and the concentration. So you can repeat the video and then try to check if there are questions. Now we can get to the exam question after this one. So we'll get the KC on the other video, the KC calculation.